Okay, hello. So today we're going to be covering a new exponent theorem that I found randomly in class yesterday. So here's how it works. So let's say we're trying to find x squared. So really this theorem is good for finding two-digit squares really fast. And so here's how it works. What on earth? I don't know what it just did. Two-digit. Okay, there we go. So if we have x squared, we can say that x is technically x plus y. X being a multiple of 10, so multiple of 10. So this would kind of be your tens place. And wow, that actually corrected it. Wow. And then y would be your ones place. So how it works is, like most people should know, there's squares up to like 10 squared, right? So 1 squared, 2 squared, 3 squared, up till 10 squared. So how this works is it basically simplifies doing two-digit squares. So here's what it is. So y is our ones digit, right? So the thing is, x squared equals y squared, okay, plus x plus y times x minus y. And so just an application. So if I was to say that x squared is 34, then this x here would be 30, basically, and this would be 4. So we could say 34 equals 4 squared plus 30 plus 34, actually 34. So this would be 34 plus 4. And can I move this all sideways? So let's move this over here. So 34 plus 4 times 34 minus 4. So, I mean, I know a lot of you must be wondering, how does this actually speed up the process? Well, really quickly, you can already say 34 squared. 16 plus 38 times 30, right? Because, actually, let me change the color. This is 34 plus 4, which becomes 38 here, right? And then this is 34 minus 4, which becomes the 30 you see here. And so mental maths with multiples of 10 is really pretty easy, because here I can simplify this to 38 times 10 times 3, which is 380 times 3, which I can immediately say is 900 plus 240, because I can use the distributive property and make this 300 plus 80, and I can distribute the 3. So I'd get 900 plus 240, which I can say is 1040. So now I have 34 squared equals 16 plus 1140, which is 34 squared equals 1156. Now, this can also be, okay, you know what? Let me delete all of this, because this is like, yahoo! Other than the equation, leave the equation up there. So you can pretty much see, like, this is a very nuanced equation. It has, like, a very specific use. But it's not only for two-digit numbers. So, for example, if I randomly said, okay, you know what? Today, let's do so 1042 squared. Now, how on earth am I supposed to do this? So, here's the thing. I can do this as 1000 squared plus, like this, right? And I can say that this is essentially 1000 squared plus 42 squared plus 2 1000 40 times 42. And so this comes from the what is it? Addition of two perfect squares formula? I'm not sure what it's called. But this basically states that x plus y all squared equals x squared plus y squared plus 2xy. So I'm going to switch my color here. So now we're going to say, so we have 1 million, forgot that comma, and we have 42 squared. So let's just quickly use that little thing here. So here's what I would say. Since 2 is our ones place, let's use that. So we'd have 42 squared equals 2 squared plus x plus y, which is going to be 44 times 40. So distributive property, and this becomes 40 times 40, and 40 times 4. So I can say that is 1,600 plus 160, which will be 1,760. So I can say 42 squared is 1,760 plus 2 squared to get 42 squared equals 1,764. And now I can say we can bring that up here. We can bring that here to say 1 million plus 1,764, which is going to be 1 million. Oh, big numbers. 1,764. And then our last step here is to multiply 2 times 1,000 times 42. So I can immediately just say that's going to be, I'm going to distribute this here because multiplying by 1,000 is, well, pretty easy. So you can say 2 times 42, which is 84. And you can just add 3 zeros at the end, so 84,000. So since here, we can bring this down here. And is that a 4? What is this? Okay. This thing is really annoying. Okay, so I can bring this 84,000 down here and add it. And this is pretty much mental math because, everything lines up. So this 84 is gonna, this 8 is gonna come here, and this 4 is gonna come here. So my final answer, oh, no, is gonna be 1,800,000, oh wait, no, 1,085,764. I just made a mistake there. I did not line that up. So this is going to become a 5. So 7, 4, 6, 7, 5, 8, 0, 1. So that is our final answer for 1,042 squared. And no, I would not have liked to do. So that equals 1042 x 1042, and then done the lengthy multiplication that this would have brought. So yeah, this is a pretty niche equation, but I mean it would be pretty useful if you're trying to do it fast, especially if you kind of memorize the equation plus this, and it'll actually be a lot faster because if you're doing like, I mean this wouldn't be that hard because you have like 2, 4, 1, and then the 0. But if you're doing like 1,780 or something like that, like a lot harder, like 1,780, this is obviously gonna take a lot longer to multiply, or 1,789, right? And so that's really, I feel like, where this kind of shines. But also, um, there's another way you can do it, which is here. So here I have 89, right? So I have technically 90 squared, which we know is 8,100, right? But we're trying to find 89 squared. So here's what we do. So here's how it works. So 90 times 90, right? Which is 8,100. Stop. Yes, good. And then we can subtract 190, right? So this would be 89 times 90, which would be 8,010. And then we can subtract 189 to get 89 squared equals 7,900 minus 79. Give me a sec to do the math. Oh my god, I am surprisingly slow. And what, 21? Yeah, 21. And if I were to do that really quick, oh, okay, and then we can also use the normal equation. So we can say 89 squared, yeah, no, we're not, no, that's not there. 89 squared equals 9, bro, equals 9 squared plus 89 plus 9 times, move it, you, times, well, 80, right? Because we know that's 89 minus 9. So 89 squared equals 81 plus, bro, what is notes doing? Plus 98 times 80, and that I don't want to do. Solve. No. Where? Yo, what? That is cool. No, here. Stop. Say at 89. Now solve it. No, solve. It Okay, so basically it kind of just lost all of my other like data. I had like 5 minutes left, but you know what? I didn't even try to recover it because I feel like this was getting kind of boring. So bye, kids. Don't do dumb stuff.